Let's solve the equation cosine of 2x minus pi over 15 equals 0 and pick out the solutions that are in the interval 0 to 2 pi. First of all, I would like for you to recall that cosine of x is 0 if x is an odd multiple of pi over 2. So x would be a number like pi over 2, 3 pi over 2, 5 pi over 2, etc. And they're negatives. Okay, now we could choose to write that in general form. Okay, pi over 2 and 3 pi over 2 are actually pi units apart. So if we do pi over 2 and we keep adding or subtracting pi, then in general we would land on the next 0 of cosine. Okay? Now, using the substitution technique I've shown you before, we would say, therefore, cosine of 2x minus pi over 15 is going to be 0 if 2x minus pi over 15 is equivalent to any one of these solutions. Now, we don't really care about the negative ones because we don't want to get negative answers, but I don't want to confuse the matter. Let's do this in general and then we can decide. Okay? All right, so this would be the general solution setup. So 2x would be pi over 15 plus pi over 2 plus multiples of pi, plus or minus, and then 2x, getting a common denominator of 30. You have 2 pi over 30, okay, plus 15 pi over 30, which is 17 pi over 30 plus pi n. So the solutions for x are generated after we divide by 2 by this formula. Okay. Now, let's take a look at what happens. If n equals 0, we get the solution 17 pi over 60. If n equals 1, we get the solution 17 pi over 60 plus pi over 2. Okay, and pi over 2 is 30 pi over 60, so this would be 47 pi over 60. And n equals 2 means we're adding 30 pi over 60 again. And we can continue in this manner. All right, so we could keep going. So let's decide how far we need to go. So let's back up a moment. If all of those solutions are in 60ths, then 2 pi is 120 pi over 60. So we could actually go pretty far with these solutions. Okay. So let's go one more time here and see what happens. If I do n equals 3, then I'm taking 77 pi over 60 and adding pi over 2. And again, remember pi over 2 is 30 pi over 60. Okay, so this gives us 107 pi over 60. If we do n equals 4, and we do the same thing again, which is keep adding multiples of the period of the new function, then again this is going to be 30 pi over 60. So this is 137 pi over 60, which is bigger than our 2 pi boundary. So we actually get 4 solutions that fit in the interval 0 to 2 pi. Okay?